Now this question is redundant connection 2. I've already done redundant connection 1. Now I'll just straight get into the code. So starting with n equals to length of edges, then this is pretty similar. So parent of v will hold the source of the first edge that we see pointing into v. It's sized n plus 1 because nodes are indexed are 1 index, and we want parent of n to be valid. 0 is just like a safe nothing here yet, because no node is ever labeled 0. Then candidate 1, candidate 2 is set to none. So these are the two competing edges into a node that has two parents. So if such a node exists, we have skip underscore index. That is where candidate 2 sits in edges. And -1 means skip nothing. Now the phase one is find a node with two parents. So each edge is u that goes into v. So v is always the child. First time we set an edge into v, we will record its source. If we ever see a second edge into the same v, we have found the node with two parents, and then candidate 1 is the earlier edge and candidate 2 is the one we just hit. And that's what we are doing over here. And this break over here is safe. We started from a valid tree where every node had at most one parent and only one edge was added. So at most one node can ever have two parents. Once found, there's nothing more to look for. And the ordering of candidate 2 and candidate 1 and candidate 2 is load pairing. Now is when we start with our union find algorithm, like the classic algorithm. So we start with parent. We start with assigning a rank or a size, whatever you want to label it. Then we start with the find function. So we walk up to the root of x's set. So this line, parent of x equals to parent of x is path halving. So before stepping up, it repoints x at its grandparent. So repeated calls flattens the structure. It's a loop rather than recursion, so deep chains can't blow the stack. Then this is the union algorithm. So if A and B are already in the same set, there is already a path between them. So this edge just closes a cycle and we just return false. So how the caller detects that. Otherwise, we merge, hanging the smaller tree under the larger one. So we can get the depth from the larger one. And then this is the classic union algorithm, which will be applied on every union find question. And this is your main loop. So we build a graph from every edge except for candidate 2. So it skips this by index, not by value. So if the input ever contained a duplicate edge, v, if it equals to the candidate, if it equals to candidate 2, then it would match and drop both copies, and the index only ever drops 1. And then if not union, so a cycle formed despite candidate 2 being absent. If candidate 1 exists, we are in case 3, so we return it. If it is none, we are in case 2, so the edge we are currently holding is the one that closed the loop. And at the end, we return candidate 2, which means we got through every edge with no cycle. So case 1, removing candidate 2 left a valid rooted tree.